Today I am going to talk about the IUPAC nomenclature of organic molecule. So first we will learn the rules which was developed by IUPAC system on the basis of organic molecular structure. So let's see. IUPAC nomenclature. So rules for IUPAC nomenclature. Rules for IUPAC First rule is the longest carbon chain, in the molecule is identical. Okay. So first one is the longest carbon chain in the molecule is identified. So I am taking an example to understand this thing. CH3, CH2, 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 CH, CH3, and here CH2, CH3. Suppose this is the molecule which I have to name. So here this is a carbon chain which has 1, 2, 3, 4, 5. 5 number of carbon in chain. I am drawing this compound again to realize clearly what I am saying. Suppose here also a chain of carbon which is 1, 2, 3, 4. So 4 number of carbon in the chain. Now I am drawing again the compound. So there is also a chain of carbon. You can see how many carbons in this chain? 1, 2, 3, 4, 5, 6. So 6 number of carbons in the chain. So according to our rule, the longest carbon chain is to be identified. So which is right? That chain must be considered. These two, because it has 4 number of carbon in the chain, it has 5 number of carbon which are less than this 6. So this must be considered. Okay, these two are wrong. So this was the first rule which I have stated. Now I am going to second rule. So what about second rule? Second rule is numbering. Numbering is started from the terminal carbon from where branching is nearest. Okay. So after identifying the chain, you have to number the carbon of that chain, and you have to start the numbering from terminal carbon. So let's take an example. CH3, CH2, CH2, CH, CH2, CH3, and this is CH3. So in this compound, longest chain we have already identified. This is the longest chain. So here, this is the terminal carbon, and this is also terminal carbon. You can put numbering from that terminal carbon. So 1, 2, 3, 4, 5, 6. Alternatively, you also can put numbering from that terminal carbon. 1, 2, 3, 4, 5, 6. So beside this chain, there is another group which is branching. This is branching. Okay. So now you have to see that in which numbering system that branching is in less number. So in this system, the branching is in 3 carbon, and in this numbering system, branching is present in 4 carbon. So we have to consider the least number according to our rule. So this numbering will not be what? Okay. So this numbering we will follow. So this was the second rule. Now I am going to take third rule. I hope you are enjoying the topic and also understood what I am saying. Third, if the two substituents are found in the equivalent position, the numbering is done alphabetically. Okay. So I am taking another example to explain the rule, that is CH3, CH, suppose this is Cl, and CH, this is Br. So this is CH3. Already you know this should be the chain, and these two are branching. So they are in equivalent position. From this terminal carbon, bromine is in 2 position, and from this terminal carbon, chlorine is in 2 position, and bromine is in 2 position. So both positions are equivalent. In that case, chlorine is started with C, but bromine is started with B. So alphabetically, which is in first position, that is bromine. So we have to put the numbering in this manner. That means the priority will go to bromine. So that will be the numbering. Okay. Now I am going to talk about third rule we have already stated. Now fourth rule. So, fourth one. If there are two chains, if there are two chains of equal size, then that chain is to be selected with which contains more number of side chains. So, I am taking another example to explain the thing. CH3, CH2, 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 CH3. So, this is not CH2, CH, CH, CH3. And this is CH3. So, if I take this chain as parent chain, so we have two branching. One branching is here, another branching is here. So this contains two branch or two branching. I am drawing this compound again. CH3, CH2, CH, CH, CH2, CH3, CH3, CH3. Suppose I am taking this chain as the longest chain. Look, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. In all respects, they are equal. So, anybody can take this chain as a parent chain or this chain as a parent chain. But the rule says, what rule says? Rule says the chain should be contained which has more number of branches. Anyway, in that case, this is only one branch. So, one branch. So now, according to this rule, which pattern I should consider? Definitely this one, because this has two branching. So this is right. This methodology is right. This is wrong. Okay. So this will not work. So that was our fourth rule. Now I am going to talk about rule number 5. The longest chain of carbon atom chain of carbon atom. I am trying to write all the things because you may collect all the things on your paper, or atoms containing the functional group is numbered in such way that the functional group is attached at the carbon attached at the carbon atom possessing lowest possible number in the chain. So that means I am telling about the functional group. The longest chain of the carbon atom containing the functional group is numbered in such a way that the functional group is attached at the carbon atom possessing lowest possible number in the chain. So I am taking an example to illustrate this thing. CH3, CH2, CH2, OH. It's a simple compound. So the carbon chain is this one. So you may number in this manner 1, 2, 3, or again I am writing this compound or drawing this compound. Same compound, and you may number this compound, this chain from this terminal carbon 1, 2, 3. So according to our fifth rule, this is the functional group. This is functional group. So functional group always be the lowest possible number. So that means this is the right methodology and this is wrong. Okay, because here the functional group is attached with third carbon. It's not possible because it also means numbered and as 1. So this numbering will be followed. This will not work. Okay, so this is the fifth rule. Then number 6. In polyfunctional compounds, suppose more than one function. In polyfunctional compounds, that means the compounds which has more than one functional group. One of the functional group, just abbreviating the functional group, okay, Fg, is chosen that is priority wise as the principal functional group. And the compound is then named on that basis. So actually, if more than one functional group is present in the molecule, then which functional group, you can't consider both functional group as a principal functional group. Numbering will be with respect to a particular functional group, which is more priority, which has more priority. So the order of decreasing priority, I am listing a table where the order of decreasing priority for some functional group are as follows. So first one is COOH. So this has highest priority. Then SO3H, so decreasing in nature or decreasing in order. Then S star COOR. Now COCl, then CONH2 acetamide, then CN, then aldehyde group CHO, then ketonic group, then alcohol, then NH2, then alkene, and least priority goes to alkynes. So this is the priority order for functional group to select the principal functional group in the molecule. Now, the point 7. Some functional groups are always indicated by the prefix instead of secondary suffix. Suffixes. These are suppose NO2. When NO2 is attached with an alkyl group, the name is nitroalkane. So nitro is prefix here, not suffix. Similarly, OR, RO R dash. Here, this is alkoxy group. So the compound is alkoxy alkane. Similarly, chloro. Suppose RCl. You will not write alkene chloride. It will be chloroalkane. When alkane chloride, it will not write as alkane chloride. It will be chloroalkane. So always they are in prefix. Similarly, bromo, iodo, fluoro, okay, and NO. What about NO? RNO. So nitrosoalkane. Nitrosoalkane. Okay. So this was the rule number 7. Now I am going to talk about the rule number 8. Secondary suffix is used to indicate the functional group. These are so I am listing the functional group, those who are present as suffix in the name. Okay. Suppose OH, that means alcohol. Suffix will be all. NH2, that is amine. It's also suffix as amine. If CHO group is present, that means aldehyde group. Suffix will be Al. Ketone. If ketone group is present, then the suffix will be -one. If carboxylic group is present, then suffix will be oic acid. Suppose CONH2 present, then suffix will be amide. COX, so suffix will be wild halide. Wild halide. Suppose COOR, that is ester group, suffix will be O8. C triple bond N, that is Cl. Cl. Okay. That is nitrile. So these are the secondary topics. So this was rule number 7 and rule number 8. Sorry. Now rule number 9. If same functional group more than one are present, consider that maximum number of functional group, consider the chain which has maximum number of functional group. Okay. So an example I am taking CH3, CH, CH2, CH2, CH3, CH, OH, CH2, CH, not CH2, CH2, then CH3, this is CH2, and OH. So, if I consider this chain, I may consider this chain. Here, OH is functional group, so both OH is present in the chain. Numbering must be from this position, okay, because that functional group is present in number 1 carbon. But from this direction, the functional group is present in second carbon. I am drawing this compound again to illustrate the thing more clearly. Suppose I take in this chain, then I have to number start from this carbon 1, 2, 3, 4, 5, 6. So here only one functional group is present in main chain, but in this compound, in this pattern, two functional group is present in the main chain. Though it has 6 carbon in the chain, but it has 5 carbon in the chain. But according to our rule, we have to adjust more functional group if they are same in that chain. So that methodology will be right, and this is wrong. I hope you understand. This is wrong and this is right. Okay. So these are the rules for IUPAC nomenclature. But these are not the only rules. Besides this, some more rules you may get from your book. So please go through the book to get more knowledge about these things. I am just discussing the important points of this topic. Okay. Now I am taking some more example to illustrate the thing more clearly. Suppose if the compound is look like this, what will be its name? Its name actually carbon containing functional group. Carbon containing functional group is not considered with cyclic ring. So the name will be cyclobutane. Cyclobutane carboxylic acid. So this kind of ring structure, if you want to name this type of compound, then you should consider the thing that ring will written separately. Okay. Secondly, I am taking another example. This is my example. Double bond, and that is OH. So two group is present, functional group. This is ketonic group and this is alcoholic group. So in priority order, ketonic group is has higher priority. Already we have learned this. So numbering will be done from this 1. After this, it may be 2 or it may be 2. But if we take this is 2, then 3 in 3 position, which group may reside. So this is 2, this is 3, 4, 5, 6. Okay. Now the name is 3-hydroxy. So in 3 position, hydroxy groups present. 3-hydroxy cyclo. This is cyclic compound. So cyclo hexanone. Hex because 6 carbon is present. So hex and none for that ketonic group. Hexanone. So this will be the name. Now another compound I am taking CH3, C double bond O, CH2, CH2, COOH. So here also 2 functional group is present. One is carboxylic group and another one is ketonic group. But according to priority rule, carboxylic group will get more preference. So this will be the chain. Here carbon is present, so it will include it into the chain. So I am giving the number 1, 2, 3, 4, 5. Here this is branching. So here the branching is this is branching. Anyway, so that compound is named as 4-keto pentanoic acid. Noic acid, why? Oic acid is due to this group. And in 4th position, there is a substitution, that is ketonic group substitution. You can also write this compound as 4-oxo pentanoic acid. This also right. Okay. If you have the option this, so put mark on that option, or otherwise if the option as this name, so put the mark on that option. Okay. So these are the example of normal IUPAC nomenclature. Now I want to talk more about some different kind of compounds like crown ether, like spiral compounds, like bicyclo compounds, like biphenyl compounds. Uh, Generally, the question from this side is not seen in exam paper. Usually, it's not seen, but sometimes it has a chance to come these sorts of questions in your paper. So I'm just discussing a few examples regarding crown ether or other things. Okay. So what is crown ether? These are crown ether. Suppose O. O. So this is crown ether. In every junction there is a carbon with CH2 group. So how many atoms in the chain? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 number of atoms are in the chain. So the compound is named in this manner 12 crown. And how many oxygens are present? 1, 2, 3, 4. So 4. So that compound is named as 12 crown 4. Another example I am taking. Suppose so how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what will be the name? 15 crown. And number of oxygen? 1, 2, 3, 4, 5. So 5. That will be the name. 15 crown 5. Okay. So it is very simple to naming this sorts of compound. Next topic is spiro compound. What is spiro compound? If two ring, alicyclic ring, are attached with a particular carbon or with a single carbon, then it is called spiro compound. Suppose I am taking an example. This is a spiro compound. So two rings are attached with a particular carbon. This is spiro. So there are two rings, one rings and two rings. Okay. And we may put numbering on this carbon chain. So that junction point, we have to choose the smallest ring. This is biggest ring, this is smallest ring. So for small ring, first carbon is assigned as 1, then 2, 3, 4, then this one 5, then 6, 7, 8, 9, 10. Okay. The compound is named as spiro. In bracket, the carbon involved to make this ring, besides this junction carbon. How many carbon? First, small ring should be considered. So 1, 2, 3, 4. So 4. Then dot. Then the bigger one. So this ring, and how many carbons are present in the ring except this carbon? 1, 2, 3, 4, 5. So it will be 5. And then bracket is closed. And then total number of carbon, how many? 10. So that is decane. Decane. We know that methane, ethane, propane, butane, pentane. So if the carbon number is 10, then compound is decane. Now I am taking another example to make it more clear. I am taking a substitution here. Okay. So now this is pyro compound, this is the junction carbon, and this is the smallest ring. So numbering will start from either this carbon or this carbon. Anyway, there is no problem. If we start from here, 1, then it's 2, then it's 3. If I take this carbon as 1, 1, 2, 3. So in both cases, chlorine is present in 2 position. So there is no problem. So 1, 2, 3, then this is say 4, 5, 6, 7, 8. So what will be the name? First substitution name must be written. So 2-chloro, spiro because the compound is pyro. Now the member in smallest ring 1, 2, 3, except this junction carbon. So 3 dot. How many carbon is present in this ring except this 4? 1, 2, 3, 4. So it's 4. So total number of carbon is 8. So 8 means octane. So the compound is 10. Right? Another example. I'm giving. Here is the substitution and 2 double bonds. So smallest thing is this one. So I am starting the number. I may start the numbering from this carbon or this carbon, but from this carbon I should take the numbering because double bond is here. So 1, 2, 3, 4, 5. Now 6 should be on that carbon only because they are the double bond. So 6, 7, 8, 9, 10. Right? So what will be the name? First substitution, that is methyl substitution because here nothing is here, so that is carbon with 3 hydrogens, so methyl. So methyl substitution, so that means in 2 position, so 2-methyl spiro, compound is spiro, and how many carbons is present? 1, 2, 3, 4. So spiro 4 dot here 1, 2, 3, 4, 5. So 5. How many carbons originally in compound? 10 carbon. So decane. So deca. But there are 2 ins. Okay, it's not that one position there is an in and in 6 position there is an in. So 1,6-diene. That will be the name of the compound. Now, bicycle compound. So what is bicyclo? If ring is fused with a bridgehead, that means this is okay. This is bicyclo compound. In bicyclo compound, there are 3 rings. Look, This is a bridgehead, this is another bridgehead, and this is another bridgehead. So three bridgehead, one bridge, two bridge, and three bridge. In that case, the compound name is bicyclo. Now put the bracket and put the numbers. Numbers are assigned in reverse order to in comparison to spiral compound. So in spiral compound we are putting the number from smaller ring to bigger ring. Now from higher number to lower number we will go. That means here this bridgehead contains two carbon, first two. This also contain two, but this contain only one carbon. So one. That will be the name. Bicyclo. And how many carbons we have in this compound? 7 number of carbon. So the compound is heptane. Similar, I am taking another example. Okay, so here this is a bridgehead with 3 carbons. This is also a bridgehead with 3 carbons, but that bridgehead has no carbon. So the compound is bicyclo. In third bracket, this is 3, this is 3, but this bridge has no carbon, so 0. And total number of carbon 1, 2, 3, 4, 5, 6, 7, 8. So 8, that means octane. So these are the bicyclo compounds. So this is the naming formula of organic compounds. Besides that, there are much more things like aromatic hydrocarbons or aromatic compounds. There is a special system of nomenclature in that case. So we'll study this later. So I think you enjoyed the topic, and if you like the video, please share and subscribe the channel. Okay, thank you.